Different people do this in different ways. So I do have a list of perfect squares. They're up on the board, but then I put them on the paper, and I also put them on the homework assignment, just if you wanted to use them up as a reference. They only go up to 12, but shouldn't be anything too much larger than that on any like tests or quizzes or anything. So how did you guys learn to break down a radical that wasn't a perfect square? Like, did you go tell me? Okay, so you did a factor tree. Okay, so if I was looking at 48, like, how do I make a factor tree for that? And there's different ways you could do it. Yeah, you know what? If you can find a number on that list that'll go into 48, that would be the best way to do. Can anybody think of a perfect square that would divide into 48? Which 16, yeah, okay, so then you can do, and if you can't, you can break this down however you want to break it down. There's different ways to do it, but if you can find one that's a perfect square, that would be ideal. So 16 does go into 48, and then 16 would just give you 4 and 4. You're looking for a pair. If you can get a pair, then you can pull that out in front. So I broke down the 16, I broke down the 48. 3 doesn't break down because 3's only factors are 3 in itself. So that pair of 4s comes out in front, and then the 3 didn't have a partner, so it stays underneath. That's literally all you have to do. But if you can find a number on that list of perfect squares that would divide into whatever's under your square root, that would be ideal to get you to do a really quick factor tree. Can anybody tell me biggest perfect square that would divide into 72? Yeah. This is 2 and 36. Now, 36, you guys know, there's your partners right there, 6 and 6. So just out in front, 6. And then I broke down the 36 and the 72. That 2 did not have a partner, so it's going to stay under the square root. If you can have a pair of partners, they come out in front. Anything that doesn't have a partner stays under the square root. What about 98? Seven roots of 2 is what you're going to get. This would be 2 times 49 if you want to do the factor tree, and then 7 and 7. There's your partnership, broke down the 49, broke down the 98, so 7 roots of 2. What about 150? Can you think of 2 numbers and multiply to give you 150? And it doesn't have to be a perfect square. There's different ways you can do a factor tree. What were you thinking? 25 and 6. Okay. Now, 25, that's a perfect square, so factors there, 5 and 5. There's my partnership. Now, 6 breaks down, right, to 3 and 2, but I don't get any other partners or anything from that, so I would just leave that as the 6. So you go ahead and pull the 5 out in front, 6 stays underneath. Has to be a set of 2 to pull it out in front. So if you don't have a set of 2, you can just leave it. Like I could break this down, like I said, to 3 and 2, but really I'm going to end up putting that back together unless I get another pair of partners. What about 80? What's a good way to break down 80? What's my thing? Yes, 16 and 5. And then 16, just 4 and 4, there's your pair, I can't speak. And then 5 stays under the square root because it did not have a partner. And I got one more. What might be a good way to break down 300? What do you think? Yes, for sure. 100 is a big perfect square. 10 and 10. There's your partners. And the 3 stays under the square root. Does anybody having a question? You're not going to have to do this on every problem today. There's a couple problems that will have it, so I wanted to review to make sure you guys know how to do this. Some of this will have nice answers that are perfect squares. Some of them will have a radical like these where you have to break it down a little bit. All right, now, here's what we're going to see. We have done 2 methods for solving quadratics. We did factoring and we did graphing. And now we are going to work on the 3rd method, which is solving using square roots, which is why I wanted to review that today. The best time to use this is an equation that does not have a linear term. And I'm going to write it like this, no bx term. And what I mean by that, like if we had our ax squared plus bx plus c, if we don't have a linear term, we have to have an x squared term because otherwise it's not a quadratic. But if we don't have a linear term, you don't have a term that just has a plain x in it, the easiest thing you can use to solve that quadratic is just to go through and solve it like a normal equation. You get the x squared by itself on one side, and then we're just going to take square roots. So you'll notice, like right here, I've got 3x squared plus 2 equals 23. There's no other term there with an x, so I can get that x squared alone, just like normal, like solve an equation. So if I was doing this question, I'd go ahead and subtract 2. I'm going to try to get the x squared by itself. That's going to be my goal here. So just subtract 2 from both sides, then give me 3x squared equals 21. Now, get the x squared totally alone before you try to get rid of the squared. So I'm going to divide by 3 there, and I get x squared equals 7. How do I get rid of the squared? Do you guys know? Like, how do I cancel that out? Yeah, square root. All right. Now, I introduced the square root into the, it wasn't in the problem as we started out, there was no square root. I introduced the square root into the problem to help me solve it. What symbol do I have to put in front of my answer? Does anybody remember? Like if you introduce the square root into the problem. Plus and minus, yes. Okay, so this question, this actually has 2 answers. And now, this is nice for us because 7 is a prime number. It doesn't break down under the square root. So it's already in simplest radical form. We don't have to do anything like we were doing above. But I do have 2 answers here. So when you introduce the square root into the problem, then you're going to have to put that plus and minus symbol. You don't have to write this, but I want to write this on this question at least. This means the square root of 7 and the negative square root of 7 are both answers to that question. Okay, let me show this to you just really, really super quick. I'm going to show you, I'm going to pull up my Desmos here in 1 second. So if I had this question and I set it, let's say I had 3x squared plus 2 equals 23. I'm just going to set this equal to 0 just real quick. This is like what we were doing in our last lesson. We'd have 3x squared minus 21 equals 0. I could graph the related quadratic like we were doing last week, just to show you this real quick here so you can see if I got my Desmos here pulled up. Okay, so I've got this graph. I kind of cheated and did it earlier just to show people. So if I graph the related quadratic and I'm looking for those zeros here, you guys see I get these ugly like negative 2.646 and positive 2.646. Those are my zeros, right? Remember, so I got 2.646. Just remember that for 1 second. I'm just going to show you on my calculator that if I just take the square root of 7, that's what that number is. They rounded it on the Desmos to 3 decimal places, but that's what it is. And then the negative square root of 7, that was just the negative version that you guys just saw in the calculator. So that's why we're just writing an exact value instead of rounding it when we leave it in the simplest radical form. But this is actually 2 answers because you can see 2 different places it crossed on the graph. They just weren't on nice numbers. Is anybody having a question? Okay. Let me look at this next one here. So I'm no x term. I've just got a 4x squared minus 25 equals 0. I can get x by itself there. There's nothing I would need to combine that with. So I'm going to add 25. 4x squared equals 25. And then don't take the square root till you get the x squared all by itself. So I'm going to divide by 4 here. And if you actually divide that, it's like, what is it? It's like 6.25. I'm not going to leave it in that format. I'm going to leave it like this. Does anybody know why it might be easier to leave that as a fraction instead of writing that as a decimal? What do you think? Yes, for sure. Okay, so what would you write as your answer? Exactly. Both at the top and the bottom are perfect squares. Like square root of 25 is 5, square root of 4 is 2. So then that's your 2 answers right there. Positive 5 over 2, negative 5 over 2. Whenever you have the square root of a fraction, you can take the square root of the top and the bottom separately. So that's where I'm getting the 5 is the square root of 25, 2 is the square root of 4. So if you see something like that, it might be easier to just go ahead and leave it as a fraction and then take the square root of the top and bottom separate. All right, similar problem. I'm going to add 64 here. All right, so I don't have an x, I just have an x squared, so I can get that x squared by itself. So I'm going to add 64. Don't take the square root till you get the x squared all alone. So we're going to divide by 2. And then this is why I was reviewing with you guys at the top, because 32, we're going to take the square root of that, not a perfect square. So I don't know why I just wrote 36. So 32. Tell me a couple numbers that would multiply to give you 32. Maybe a perfect square. Yes, ma'am. So this is 16 and 2. So that breaks into 4 and 4. There's your pair right there. So this would be, don't forget the plus minus. I just left no space for that. So plus minus, it would be 4 roots of 2. And again, it would be 2 places on the graph. It's just that plus minus symbol is a little shorthand way to speed that process up. And I'm going to do one more. Today I'm going to have a different, or tomorrow we're going to have a different answer to this question. But for our purposes today, I'm going to subtract 9 from both sides. And I get x squared equals negative 9. And take square root of this. If you actually tried to do this on your calculator, I grabbed your calculator and you said, okay, square root negative 9, and you were actually on the screen so you could see it. If you did this, you're going to see any calculator you should have. This should give you an error message. You can't find, when you take square root of something, it's 2 numbers multiplied together to give you whatever's under the square root. There is no way in a real number situation that you could get 2 numbers to multiply to get you negative 9, right? Because I could do 3 times 3, that's positive 9. If I did negative 3 times negative 3, that's also positive 9. There's no way, right now, maybe some of you know this, but for today's purposes, there's no number right now that I could multiply together by itself that would give me a negative 9. So for this question, I'm just going to say this has no real solution. We're going to talk about imaginary solutions tomorrow, but no real solution for this question. Anytime you get a square root of a negative, no real solution. All right, now these guys on the back look a lot more complicated. And I'm going to give you one recommendation right away. So we see the parentheses, right? And a lot of times we were multiplying these out in our last unit, which is an excellent skill. But if you're solving an equation, do not foil any of the, don't foil or box or whatever you use. Do not foil any of these questions if it's an equation that you are trying to solve. Like if I'm trying to write it in standard form, we got to do it. But if it's an equation I am trying to solve, you want these parentheses. And trust me, they'll make it so much easier to work with. So don't foil this. Okay, whatever's in the parentheses, I want you to treat that like a giant variable. Just pretend like that whole thing is just x squared. I know it's more complicated than that, but just get that by itself on one side. So to do that, I'm going to get rid of this 6, just subtract 6. And you don't want to distribute into that set of parentheses, right? Our order of operations. We'd have to square it first, but we don't want to do that. So don't distribute. You want to actually get rid of that 3 in front of those parentheses. You're just going to divide. Now, here is why I don't want you to FOIL. If you take 48, divide that by 3, that's 16. Here's why I don't want you to FOIL. You can actually just get rid of that entire set of parentheses by taking a square root right then and there. As long as those parentheses are by themselves, the square root and squared cancel each other out. And so here, now you just drop the parentheses, but you still have x minus 2, like that's still there. The other side, I got to do the plus and minus symbol, and then I'm going to take the square root of 16. That's actually a nice set of numbers. You got 4 and negative 4. All right, now to solve the equation, here's what I would tell you to do. I got to move this negative 2 to the other side, so I'm going to add it. And then what I always tell people to do, just write that number, the 2. I'm going to write that right after the equal sign. So I have 2 plus or minus 4. Now, depends on the question, but for this example, you can actually add 2 to 4, and you can actually subtract 4 from 2. So if I do 2 plus 4, one of my answers is 6. If I do 2 minus 4, my other answer, -2. Completely fine to do, as long as it's a plain number. If it has a radical attached to it, you can't do that. But if it's a plain number, then we're good. So you want those parentheses alone on one side, and then don't FOIL, you're going to take a square root. All right, what would I do? Just somebody raise your hand and tell me, what would you do first for the equation I got there in the middle? I've got 2, and then in parentheses, 4x plus 3, that's squared equals 128. What would you do first for that question? What do you think? Divide by 2. Right. So I got 4x plus 3 squared. Oh, what is that, 64? I think so. Okay. What do I do next? Square root. All right. So square root of 64 would give me what? You guys know? 8, thank you. Okay, it's okay to talk. All right, plus or minus 8. All right, now, there's different ways you could do this, but I'm just going to walk you through what I would do. So I'm going to do kind of like I did on the last question. It's a little teensy bit more complicated because I've got a 4 in front of the x, but here's what I'm going to do. I'm going to subtract 3. And when I do that, I'm just going to write that directly after that equal sign and keep that plus minus symbol with that 8. All right, and then I got to get rid of the 4 in front of the x so I can get it by itself. So I'm just going to divide that whole thing by 4. Now, when I do my answer, I'm just going to do 2 separate little fractions here. Okay, we're going to do -3 plus 8, divide that by 4. And then I'm also going to do -3 minus 8, divide that by 4. If I can, let me scooch that up a little bit, sorry. All right, now, when you simplify this, go ahead and figure out whatever the top of the fraction is first, and then see if you can reduce or whatever. So no, this is just -3 plus 8, so that's 5 over 4. That doesn't reduce. The other one, -3 minus 8, would be -11 over 4. That doesn't reduce either, so that's going to be my 2 answers right there. Just leave them as fractions. And then I have one more question here at the top. What would you do first on this last example? I've got x minus 3, it's squared all over 5, and then equals 9. Jill, what do you think? Yes, get rid of the fraction. All you got to do, multiply both sides by 5. All it's going to leave you on the left side, just that x minus 3 squared, and then 9 times 5 would give you 45. All right, now this is kind of like those review questions that we were doing at the very beginning of class today. So I'm just going to take a square root, but 45 is not a perfect square, so we're going to see if we can break that down. This side would just be x minus 3. Let's see if I can leave a little space over here. Tell me 2 numbers you'd multiply together to get 45 to maybe help break it down. 5 and 9. Good. Now, 9 is a perfect square. It breaks down to 3 and 3. There's your partners right there, and 5 is left under the square root. So don't forget, because I almost did the plus and minus symbol, this would be 3 square roots of 5. Now, this is going to look different than the last 2 questions, but I'm still going to get x alone. I'm going to need to add this 3 to the other side here. So I'd have x equals 3 plus or minus 3 radical 5. Now, the only difference here, you cannot actually add 3 to 3 radical 5. They're not like terms. So this is 2 separate answers here, but this is just how you would leave it, because you can't actually combine those. That radical 5 kind of screws everything up. So don't write like, oh, it's 6 radical 5. It doesn't work like that. You have to have like radicals to be able to add them together. So I just have a plain number 3, and then I have 3 radical 5, so they don't get combined. You just leave them as 2 separate terms there with that plus minus symbol in between. Does anybody have a question? All right, now a little application problem at the very bottom here. So this says the function h equals -16 t squared plus 270 models the height in feet of an object t seconds after it's dropped from the top of a building that is 270 feet tall. Now, you absolutely do not have to write this, but I just want to explain this to you guys real quick. Now, when we looked at this formula before, it did have a middle term. It was velocity multiplied by time, and then c is the initial height. So for this example, it's the height of the building. The reason this does not have a middle term, do you see in the question it just says I'm dropping the object off the building? So I'm not like throwing it. So I'm not giving it an initial speed. If you just drop something, or if it were to like roll off the side of the building, it doesn't have a velocity. I forgot the squared in this, forgive. It's just affected by the force of gravity, which is the -16. But that's why there's no middle term here, which is nice for us because we can just use square roots to solve both of these questions we're about to do in a second. But I just wanted to explain, there's no middle term there because I'm not throwing it or doing something like that that would cause the object to have any additional speed other than the gravity. Okay. Now, here's what my question is. It says, after how many seconds is the object going to be 206 feet off the ground? So, after how many seconds means I'm going to end up solving this for the time here. What would you do with the equation, because that's really all we have, and the 206? What do you think? Heck yes, you do. All right, this is in feet, right? The height is in feet. So all you're going to do, you're going to plug in the 206 for the height in that lovely formula that they gave you. So here's the equation we'd be solving. 206 -16t squared plus 270. And again, I don't have a term that's just a plain t. We just have that t squared, so we can totally get that alone by itself just by solving this like a normal equation. So I'm going to subtract 270. Don't worry, this is going to give me a negative, but it's going to get canceled out by that -16. So 206 minus 270 is -64. And this is equal to -16t squared. Don't take a square root until you get the t squared by itself. So -16, I'm going to divide by that on both sides. And the negatives then cancel out there. So we're going to end up with 4 equals our time squared. Okay, now I'm going to put my square root and get t alone by doing that. Why am I not going to write a plus and minus symbol on this question? Does anybody know? Like algebraically I should write a plus and minus symbol, but if it's attached to the situation, why not? Exactly. Okay, so a lot of these, I don't want to say every time, but almost every time. You don't want a plus and minus on this because can't have negative time. Right, I can't have -2 seconds. It doesn't work like that. So when you do this, algebraically, if I just gave you the equation, it'd be plus or minus 2, but because it's attached to this situation, it's just going to be 2 is going to be my time, so it'd be 2 seconds for the object to reach that height. So any of these that are like a word problem, it's probably going to be a good thing to think through. Should I put the plus and minus symbol? All right, now same formula, same situation, but this one's just a little different question. So it says, after how many seconds will the object hit the ground? And you're not going to break this down or anything. I'm just going to have you guys use your calculator to estimate this. We're going to round it to the nearest hundredth of a second when we actually answer the question. So again, how long, or after how many seconds, so I don't know the time here, is my object going to hit the ground? What is your height if you're on the ground? 0, right? Okay, if you're on the ground, you know how many, right? You're on the ground, okay? So all you're going to do anytime a question asks you, how long does it take the object to hit the ground? Just plug in 0 for the height. So exactly same equation, we're just going to do 0 instead of where we put the 206. Now, this one is not going to have a nice answer when you do this, but what we want to do, take the 270, subtract that from 0, so we would have -270. And the negative's going to cancel out, so it's going to be totally fine for us to take the square root here. If you do this, bless you, it's not a nice number, so since they asked me to round to the nearest hundredth, I'm just going to go ahead and write the entire decimal out. If you divide this here, you should get 16.875. And that's what I want to take the square root of. And really similar to that last question, I'm just going to check that real quick. Yes, okay. So I'm just going to do my square root key on my calculator. If you guys don't know where that is, it should be second, and then, bless you, button, it's like right diagonal from the 7. So if you see that here, if you're not used to the square root button, I should have showed you that earlier. It's a second, and then this, it's like, what is it, like the 6th button down on the left side. That's the second function for that one. And then I'm going to just type that 6.875 in there, and we're going to round to 2 decimal places. This one's not a nice answer. No plus and minus on this because, again, we can't have negative time. So I would say this one is about 4.11 seconds until the object would hit the ground. Is anybody having a question?